Hello everyone. Today we're going to go over a fast way of multiplying 2 or 3 digit numbers. So this is kind of based on what you would know from expanding brackets in algebra. So you've got this ax plus b, oh wrong color, ax plus b times cx plus d. And in order to multiply them out, you would do something like FOIL, F-O-I-L. So you do first, outer, inner, last. So AC x squared plus BC, well, BC, and then inner AD plus AD x plus BD. That's an algebraic way of expanding. Another way you could treat this is like 3x plus 2 times 4x plus 5. How might you do this? Well, first, outer, inner, last. 12x squared plus 2 times 4x is 8x, plus 3 times 5 is 15x, 3x and 5 is 15x, plus 2 times 5 is 10. So what if I said, let x be 10, okay? Let x be 10. Then this 3x plus 2 becomes 32 because each term is in the form of one digit in units, tens, hundreds, so on. And correspondingly, this second bracket, 4x plus 5, becomes just the number 45 in units, tens, so on, because each term is one place in the place value of this polynomial. Or when I say polynomial, it's really a number. It's just any old number. So 32 times 45, well, this algebraic multiplication that we did earlier still holds true. First, outer, inner, last. So you've got 10 here plus 15x. Well, x is 10, so we just move that all one digit to the right. Let's draw this a little more spaced out. 10 is one term. 15x, so if this is 1, this is x squared, this is x cubed. Well, fake x cubed because x is just 10. This is more like units, tens, hundreds, thousands. Well, 15x, well, it's in the x's, so let's just write 15 plus 8x plus 12x squared, right? And if we add these all up, we will naturally get the answer to this multiplication, 32 times 45. And in this way, we really didn't need to do that much. This is kind of how long multiplication works, generally speaking, but it's a different way of going about it, because you are naturally more inclined to learn how to do brackets, and it's easier to do the multiplication first than all of the adding second. So that's the first level of speeding up your multiplication. The next level is leaving out the x's altogether. So you've got these numbers to multiply together, 3, 2 times 4, 5. You do first, outer, inner, last. So there's 12 hundreds, and then in the x column you've got, well, outer, 3 times 5, 15, inner, 2 times 4 is 8, and in the units column you just got 2 times 5 is 10. And then you do that addition because you are already comfortable with the idea of the first, outer, inner, last stuff. You're already comfortable with doing that in your head. You do the addition and you get 0, 1 plus 5 is 8, 14. Carry the 1, 4, 1 here. So that's the next step. So how might you take this a little bit further? The next step is foregoing this table of working. Just don't write it down. That's one way to speed up the process. So say you've got 69 times 4t2. I've said that in a weird way to emphasize how you can treat these kind of like algebraic expressions in their own right. So what do? Well, let's just draw a line under it and start writing the answer. 9 times 2, 18. Well, let's carry a 1. 6 times 2, 12, plus 9 times 4, 36. 12 plus 36, 48. So we've got 48 in this part. 48 plus 1, this carried 1 goes into the tens because this is representative of a 10. We get 49, so carry the 4. And then finally, the hundreds digit, because as you notice, we've started from the units digit now. Hundred digit is the tens times the tens, 6 times 4, in this first outer inner last mentality. 6 times 4, 24. 24 plus 4, 28. 2898 is our answer here. So that's yet another way of multiplying. What next? How could something possibly get faster than this? Because this is already pretty fast. Well, the thing is, you've got to consider what happens when you add more numbers in. So sure, this might be pretty fast for 2 digits times 2 digits. 6 times 5, 30, carry the 3. 3 times 5 is your first outer to inner, because really you're starting like this, and then you're going from this to this. Whoops. Is you've got your first layer calculation, which is just this, then your second layer, which is like this, and then this, and then your third layer, which is like you start from yet another one out, so like this, 5 times 0, 136, and 4 times 36, to go on. But anyway, let's just keep doing this. 5 times 3, 15, 6 times 4, 24, 15 plus 24, 39. 39 plus the carried 3, 42. Right? 3 times 4, 12. That's a 10 times a 10, so it's 100. And that's 12 hundreds plus a carried 400 goes to 16. 1620. But, how does this help? Because when you get bigger, what are you going to do? Well, the systematic way of knowing how to multiply when you are foiling is by taking it 1 digit at a time. And that's actually what you do in long multiplication already. If you had like 1, 3, 1 times 2, 1, 1, you'd first multiply everything by the 1 digit, and then you'd multiply everything, and then you'd multiply everything by the 10 digit, and then you'd multiply everything by the 100 digit. And then, after all that, you finally do your adding to get to the answer. But anyway, the point I want you to look at here is that you're doing it 1 digit of the smaller number at a time. So it doesn't matter really which side is which, but as long as the number with fewer digits, even if it's like 999 times 1, 2, 3, even though this is bigger, it's important that the number with fewer digits, or one of the numbers, if they are the same number of digits, is on the right-hand side, because you'll do it by digit. You start with 10 to the 0 here, and you want your first target is numbers that end in 10, that begin with 10 to the 0, because you want units. So you do this 9 times 3 thing. And then your next target is numbers that start with tens. So you do this units times tens business first, and then you move on to tens times units. You're moving inwards in the calculation. And then you start looking for hundreds. So if you're starting with units and you want hundreds, then you better start by multiplying that unit by hundreds first. So units times hundreds is hundreds, tens times tens is hundreds, and hundreds times units is hundreds. And you notice how you're going in one step each time. So that's a systematic way of doing FOIL for larger brackets. And this applies also in algebra if you're doing like 3x plus 2y plus z times 1x plus 2y plus 4z. Well, you might do z times everything. This is like first, outer, inner, last on steroids. You do basically units, and then once you're done with that, you do tens. And then once you're done with that, you do hundreds. Once you're done with that, you start moving further along, because once you've reached the end of this number, there isn't really anywhere else to go, right? So you could add some ghost terms here to continue this sort of inward movement. Which you do by adding ghost digits. And you want thousands, so you go units times thousands, tens times hundreds, hundreds times tens, so on, and so on and so forth until you're done with writing out, because you'll know you're done with the equation when it's continually 0, because 3 digits times 3 digits at most will make 6 digits, for instance. Okay, so what next? What do you do with this information? How does it apply to multiplication? Well, it applies in this case of our 123 times 999 quite well. It enables us to find the answer to this question. So we put some 3 phantom zeros in the front because 999 is 3 digits. So 9 times 3, our units, is 27. So 7 carry the 2. 9 times 2 is step 1 of tens. 9 times 3 here is step 2 of tens, because you've got units times tens here, and then tens times units here. So it's 18 plus 27, and that's 45. And 45 plus 2 carried becomes 47. And then you do the hundreds digit. So the first step is units times hundreds, 9 times 1. The next step is 10 times tens, 9 times 2. And moving inwards again, the next step is 9 times 3 for hundreds times units. And of course, all of this is very possible to do mentally with 2 or 3 digit numbers with some practice. Doing long multiplication in your head is probably not possible mentally, but this is. Because the hardest thing you'll have to remember at any given time is summing up to only one digit. After you've written down that one digit, it helps you with your calculation, so you can just keep going. So for instance, 9 times 1, 9, 9 times 2, 18, 9 times 3, 27, 9 plus 18 plus 27. Well, that's just like 6 times 9, 54. So 54 plus 4 goes to 58. That's our third digit. And of course you can write it down if you want to. You can make like a working space underneath here where you've written down 9, 18, 27. But I would argue that that kind of defeats the point, because training yourself to do this addition in your head allows you to go way faster when multiplying these two numbers. And if you're doing something like the BMAT or the PAT, your engineering tests, whatever, it is unlikely that they will make you do non-calculator arithmetic of more than 2 significant figures times 2 significant figures. Anyway, let's keep moving. Once you're done with the hundreds step, you move on to the thousands step. So units times thousands digit, well, that's 0. Tens times hundreds digit is the next way to get thousands. So that's 9 times 1 is 9, and hundreds times 10 digit is the next way to get thousands. 9 times 2 is 18. 9 plus 18, 27. 27 plus the carried 5 is 32. And for the last one, I'm just going to draw some dashed lines to show where I'm going. So say you've got this units 9, and you want your next digit is 10,000s. Next place value is 10,000s. So units times 10,000s makes 9 times 0 is 0. Tens times thousands makes tens thousands also. And finally, hundreds times hundreds makes tens of thousands. And that's just 9 times 1, since these two are 0. 9 times 1 plus the carried 3 is 12. And your last digit, you may notice, your last digit is always going to be 0. 0 because the 3 digits on here now correspond to the 3 things you multiply by starting from this end. So units times 100 thousands, tens times tens of thousands, and hundreds times thousands to get hundreds of thousands won't give you anything new beyond what you are carrying here, because it's like a polynomial with x squared plus da 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 times x squared plus da 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 da, and the highest power of x it can go is x to the 4. These tens of thousands, if x is 10, as is used to describe any number that we're using in arithmetic. So x to the 4 might spill over a little bit in x to the 5, but it will never generate x to the 6's, because the coefficient of x to the 4 is always going to be between 0 and 9. So this 1 just carries down to get 1 here. The answer to this question is 122,877, and we did not write down any working below it at all. So here's another practice question. This time I'm not going to draw out the arrows so we can get a bit more used to doing it. 384 times 27. So 7 times 4, first step, units, 28. Second step, tens. Units times tens, 10 times units. 7 times 8, 56. 2 times 4, 8. 56 plus 8, 64. 64 plus the carried 2, 66. Next step, hundreds. Units times hundreds, and then tens times tens. 7 times 3, 21. 2 times 8, 16. 21 plus 16, 37. 37 plus the carried 6, 43. And now let's add our phantom zeros, because we have 2 digits here. Let's add 2 zeros to the right. Our next step, the thousands digit, because this is the blank entry. Units times thousands, 7 times 0, nothing. And then tens times hundreds, 2 times 3, 6. 6 and the carried 4 goes to 10. And finally, last digit. We're aiming for tens of thousands. 7 times tens of thousands, 0. 2 times tens of thousands, 0. So we just take the carried 1 and call it a day. And our answer to this is 10,368. I hope this video helped you. If you find this kind of non-calculated arithmetic to be annoying to do, I hope it has sped up the process for you, and I'll let you in on a little secret. There is a way that is even faster than this, detailed in my source, where I got it from. That is a book called Trachtenberg's Speed System of Basic Mathematics. And it was developed by a Polish at origin engineer / social activist who was imprisoned in a Nazi concentration camp when he was trying to pass the time, and was luckily able to be written down afterwards because he survived, not with any ease. So this legend made up this system and published it for the world to use, which has probably done wonders for us in the time before computers, in the few decades when this was available. And I'm going to be including a link to a website detailing this method in the description. It is not a website owned by Trachtenberg's estate, it's just another fan of this method. But if you would like me to teach that second, even faster multiplication method than this, then leave a message in the comments, or email me at watchmedomath@gmail.com. You've been watch me do that, do math, and there are new videos every Tuesday, Thursday, and Sunday at 6 p.m. Hong Kong time or 10 p.m. Universal Coordinate Time. Subscribe to this help you, and thank you for watching.